Assalamu alaikum. My name is Abdulmuhsen Alzahrani. Today I'll be presenting ultrasonic bone densitometry for the course EE 472. First, for the introduction, many health conditions might happen when we age. One of them is osteoporosis, which is defined as low bone mass, deteriorating bone structure that leads to an increase in bone fragility. Although osteoporosis can happen anywhere on the body, it is more common in elderly women in the spine, hips, and wrists. In current technology, the devices used to measure bone mineral density, or BMD, are dual X-ray absorptiometry, or DXA, ultrasonic bone densitometry, or now known as ultrasonometry, and a software application for CT scanner. So what is ultrasonometry? Bone ultrasonometry is used to measure bone mass in peripheral sites like the tibia, wrist, and more commonly the heels. The types of bone tissue, which are cortical and cancellous, can be affected from aging. Cortical bones can become more holy, so they will have more holes, and cancellous bone integrity is decreased. Bone ultrasonometry uses the same principle as ultrasound imaging, and it can do it using two techniques. The first technique is called the transverse transmission technique. This technique sends an ultrasound pulse through the bone by having two transducers on opposite sides of the studied bone, acting as a transmitter and receiver, as shown in the figure. This method takes the broadband ultrasonic attenuation, or BUA, expressed in dB per megahertz, and the speed of sound, SOS, of the bone and compares it to a reference medium with known attenuation and speed, like water. The BUA, or broadband ultrasonic attenuation, is obtained from a spectral analysis of the transmitted and received signals. And since ultrasonic attenuation changes linearly with frequency, the used frequency range to get the BUA value is between 0.2 and 0.6 megahertz. As for the speed of sound, the time of flight from the transmitted signal is calculated into speed of sound using time domain methods. And for the second technique, it's the axial transmission technique. This technique uses transmitter and receiver transducers placed on the skin along the bone to measure the velocity of the ultrasound along a fixed distance of the bone. The signal propagates along and below the surface of the bone, as shown in the figure, and the transducers measure the time of arrival of the signal, so it can be calculated into velocity. Finally, for the conclusion, we've learned what bone ultrasonometry is and what osteoporosis is, and how to detect it using two techniques. The first technique being the transverse transmission technique, which works better with peripheral sites and sends the signal through the bones. And the second is the axial transmission technique, which has two transducers on the skin. Thank you for listening.